Section 7.8 is about inverse functions and relations. An inverse relation is a set of ordered pairs that you obtain by reversing the coordinates on an original set. So if I say that Q equals this set of ordered pairs, it's easy enough to find the inverse of that function. All you do is take the x and y values and flip them. So negative 4, 3 becomes 3, negative 4, and so on. Now an inverse function, the definition is given for us here. Suppose f and f of negative 1. This is how we write a function and its inverse. We use a negative 1 exponent on a function, and that's how we talk about its inverse. That only applies when the domain and the range can be flipped in either one of those functions. So here's an example of a function where I'm asked to find the inverse of that function. So here's what I do. I replace the f of x with a y, because remember the f of x and the y are the same thing. That's the domain and the range. And now according to the definition of an inverse function, all I have to do is exchange the domain and range, flip them. Now I'm going to solve for my y and put it back into a regular equation notation. So I'm going to solve both sides by 2. 2x equals y plus 6. Subtract 6. Then we'll put the y on the left, so y equals 2x minus 6. And the last thing I'll do is I'll put it back in function notation to show that it's an inverse function. So the inverse function is 2x minus 6. So now I'm asked to graph the function and its inverse. So let's graph the function here in blue. If I put a number in like a 0, I get a 0, 3. If I put something in like 2, 2 plus 6 is 8, 8 divided by 2 is 4, so 2, 4. And I can graph that line. Now I'm going to graph the inverse in purple. If I do something like a 2 also for that, 2 times 2 is 4, and 4 minus 6 is negative 2. If I do a 3, 3 times 2 is 6, and 6 is 0. 6 minus 6 is 0, so I can graph that line. So here we see the blue is the function, and the purple is the inverse function. Now you also might notice that if you draw an imaginary line right down the middle of them, which is y equals x, then those two functions are the reflection of that line. Now in this key concept, we're told that two functions are inverse functions if both of their compositions are the identity function. Now the identity function is sometimes written this way, I of x equals x. And it just means that when you plug in x, you get the same thing. You get x out. So if we take the composition of these two functions and we get x, then we know that these are inverse functions. Let's start the first composition by finding f of g of x, which means that we're going to put g of x into all the x values for the f function. So we're going to do 5 and then times x, and instead of x we're going to put the g of x function into that, 1/5 x minus 2. So now distributing here we get an x, and 5 times negative 2 is negative 10. Negative 10 plus 10 is 0, so we get x. So this part's good. When we do the f composition with the g, we get the identity function. Let's see if it works the other way around. So now we're going to do g of f of x. So we put the f of x into the g function. So 1/5 and then times x, which we will put the f function into that, and then minus 2. So distributing 1/5, we get x plus 2 minus 2. Those will go away and we'll get an x. So that works. So we know that the f function and the g function are inverse functions. Now when you have a function that has an inverse that is also a function, then we say that the original function is 1-to-1. Now how do we check that? How do we check if the inverse is a function? Well, we use the horizontal line test. If you remember, we've learned about the vertical line test, which checks to see if things are functions. But now we're going to use the horizontal line test to check to see if the inverse is a function. So in this example, if I take a horizontal line and I slide it left and right here, I notice that it never touches more than one point at the same time. So then this inverse would be a function. But if I use a horizontal line test like that horizontal line, it touches two places, then we say that this inverse is not a function. And that works when you're trying to find out if an inverse is a function.